A mobile GIS application provides a channel of communication directly to both office personnel and field users. This helps to solve two critical business problems in a public works department: accessing an accurate database and streamlining work processes at the site. In the following scenario, imagine that you are a member of a public works field crew whose task is to clean out a catch basin. A wireless mobile GIS application displays the route you will follow to the site and describes the assets scheduled for cleanout. It provides up-to-date access to the asset database in the scheduling system. This information is stored on your mobile device, so you can see the data you need, whether or not you are in an area where you can connect to the network wirelessly. The area where you are scheduled to work today is not in an area of connectivity. The data you have, however, is current, because while you were in a connected area, you received it from the web server onto your mobile device. You once used a paper map book. Now, with the wireless mobile GIS application, you have up-to-date information to help you complete your daily assignments more efficiently, because the application is communicating with the office. You follow the GIS computed route to get to the work site. Before you arrive, you look up some preliminary information. The digital map gives you meaningful information and is more legible than your old paper map. The database shows you the catch basin's last clean date, the invert, access type, and grate type. After you are done with the cleaning, you update the last clean field for this asset. If you were connected, this change or completed work order would automatically be sent to the office. But you do not have coverage here, so the data is saved on the mobile device. GIS has not only efficiently replaced your paper map books, it has also streamlined the work order process by entering field data back into the main database. Time is no longer wasted producing these map sheets and updating them with completed work orders. Field crews need accurate data. If an asset is mislabeled or not in the correct location, a worker can waste a lot of time trying to find it, or may even have to return back to the yard to get the proper equipment for the job. Typically, the worker would redline these issues in the map book to note the inconsistency. The mobile GIS application allows field workers to note the discrepancy, communicate this information to the asset database, and ultimately share the redline edits with all crews. Users can even flag these red lines with an asset ID and note some information about the error so that data editors can fix the problem. For instance, when you arrived at the catch basin, you saw that the asset on the map was located on the wrong side of the road. The error may be the result of an incorrect as-built CAD file. Now that you are at the site, you can make the correction. Use the redline function to mark this asset and show that it needs attention. Add a description of the problem and set some attributes so the office knows that this is not just a field note. The last step is to sketch the red line around the asset. You will notice the GIS automatically copied the asset ID from the catch basin. This added ability to share notes has increased field workers' overall efficiency and awareness of issues with the physical network. This means that staff, both in the field and in the office, are more prepared to address all situations. Seamless communication between the field and the office means that the accuracy of the asset database can be continually improved. Everyone in the organization can contribute to and benefit from this up-to-date spatial asset information. You are headed back to a connected area, so you reconnect to the server and then submit the changes. Once you see the connection change back, the edits will automatically be posted. Now imagine that you are a staff member working at the office and are receiving data in real time from the field. The field data received with red lines are set to notify the data editors. Because the municipality has confidence in the field crew's entries, the completed work orders are saved directly to the master database. The application also allows these changes to be saved to a temporary location, so they can be reviewed and approved prior to adding them to the database. Using a desktop GIS application, you can refresh the map to see all newly identified issues. Near the center of the screen, you can see the note that was just posted by the field crew. In a closer view, you can see that the field crew is saying that the asset is on the wrong side of the street. A response might be to send out a crew to survey a proper location, but you are used to dealing with this type of problem. By looking at the aerial photo, you can see the proper location on the opposing curve. Using an editing tool, drag the catch basin to the proper location. Note that the sewer main connected to it is automatically adjusted. This shows that GIS understands the spatial relationship assets have with each other. Once you have taken care of the issue, you can delete the red line. This way, the field crews know the issue has been addressed and that their hard work is making a difference. Field crews can refresh the map and see that the asset has been adjusted and that the red line is now gone. The municipality is now able to use its field staff as the eyes and ears of the Public Works Department's database, resulting in highly accurate data. This is the power of the geographic approach. The mobile server and desktop framework provides the correct tool for the job that is being done. Even though each of these tools was designed for a different purpose, they are still accessing data from one central location.